Hey Ryan.
How you doing?
Good. How are you?
All right.
So do we need to go back to the same site?
Yeah.
Okay.
Yep. Yep.
And
It'd be 11:4.
hmm Okay. Now we talk about volumes also.
Yep.
This is a rectangular brick. What's the volume of a rectangular brick?
I don't know.
It's the product of the three dimensions. So it's the base times the width times the height.
All right. So go 24. The base is 24 times 4 to get the area of the base.
Right.
Right.
Mm-hmm.
Let me get my calculator out and do that. 4 times 4. And that's 96. So then you do 96 plus the height.
Times the height. It's always times when you're doing volumes.
And that gives you 192.
192, right. Okay. Now, what you said there was the way you find the volumes of all prisms, which is you find the area of the base and you multiply it by the height.
All right.
So in this prism, we have a triangle that is a right triangle. Let me bring up my drawing tablet here. Okay, so our triangle what are the dimensions on this triangle?
3 and then 6.
Okay, so what's the area of that triangle?
Um, 9, 36. Add those and then
Hold it, what's the area of just this triangle?
base times height divided by 2.
So that would be 9.
Right.
Okay, now to get the volume of this prism, we're going to take the area of that triangle times the height.
All right. How do you get the base then? Like, would you just do 9 times 9?
No, you had the area of the base is 1/2 base times height. So it's 1/2 times 3 times 6.
Where
So
are
that's
you
where we
getting,
got the 9 from.
where are you getting the
9,
3 from?
9 meters squared. The base is 3, this dimension right here.
Okay.
In other words, when I'm talking height of this triangle, I'm talking 6. I'm not talking height of the prism. In
All
other
right.
words, the very first thing I have to do is figure out the area of the base. And the base, if you were to look at it from a bird's eye view, the base has a base of, or the triangular base has a base of 3 and a height of 6. So this area is 1/2 base times height, so that would be 9. And then
All right.
whatever the area of that base is times the height, which also happens to be 9, gives us 81.
Okay.
Okay. What do we have here?
So you'd break that down, wouldn't you? Into two different ones?
Well, first of all, when you have a rectangular brick or a rectangular prism, it's always just the product of the three dimensions. But if you want to look at it as the area of the base, which would be 14 times 15 times the height. So it'd be 15 times 14 times the height, 9, which ends up being the product of the three dimensions.
All right, so
what's that number?
It gives you 1,890.
Okay. Find the volume.
When I was asking that question, if we break that into two parts, I was thinking we were on 4 because I saw that one.
Okay. I thought you meant by the two parts, the base and then the height.
Right.
Because all prisms come down to that. In other words, even this one, we figured out the base of the triangle, the area of that base, multiplied it by the height because it's consistent all the way up. It's not like a cone. We couldn't do that to a cone because a cone has a circular base, but it's not consistent all the way up. It would be a cylinder if it was. So if we had the area or the volume of a cylinder, we're going to find the area of this circular base, multiply it by the height. But if we have the volume of a cone, we can't do that. A cone is not a prism. It does not have opposite parallel bases.
Okay.
All right, so let's get to number 4. Yeah, on this one we just break it up. And notice that when you're talking volume, it doesn't matter if things are joined together. It's going to be the volume of this rectangular brick plus the volume of this rectangular brick. However, if we were talking surface area, it would make a great deal of difference. Because if we were talking surface area, the normal right side of this rectangular brick is covered up. So it wouldn't count for surface area. So this would be a much harder problem to do if it was calculate the surface area of this. Volume is easy. It's going to be the volume of this brick plus the volume of this brick. So what's the volume of this brick here?
196.
Well, what are its dimensions?
7, 4, and 7.
What's that number again?
196.
And the volume of this brick here?
So you do 2 times 7 times 5, and that gives you 70.
One moment.
266.
Where did we get? Okay. Sorry. No, okay. 266. Yeah.
Yeah.
Okay. And the volume of this prism.
All right. So you do base times height divided by 2. So you got 25 times 19.
Correct.
That gives you 475. And then when you're doing volume, it's always meters or whatever cubed, right? Like units cubed?
Right. It's 3 dimensions. In other words, let's go over the 3 different dimensions. The length of this line is 5. That's 1 dimension. That's 5 inches.
Okay.
The area of this rectangle is 10 square inches because it's 2 dimensions.
Right.
And the volume of this rectangular prism is 2 times 5 times 3, 30 cubic inches, because it's 3 dimensions. 3 dimensions is always volume in cubic inches. Area is always square inches and 2 dimensions. And scalar measurements are always 1 dimension.
Okay.
All right. So let's see. We need to go to the next one, huh? Should I hit try again? No, try again would do the same test again.
Yeah.
I need to go backwards to 11.5. 11.5's next, is that right?
Yeah, and I think that's the last one.
Okay.
I'll put that up real quick. Yeah, it's the last one.
Okay. Volume of a cone. First of all, let's talk about the difference between a cone and a cylinder.
All right.
If we were to take a cylinder, what's the volume of the cylinder?
Wouldn't it still be radius pi times lateral?
Well, it's pi r squared, the area of the base, times the height.
Okay.
So pi r squared times height. So the area of a cylinder is pi r squared times height, sticking with the same principle we've been working with, that if the solid is uniform all the way up, then you just take the area of the base times the height. And it doesn't matter if the base is a circle, a triangle, a rectangle, a parallelogram, doesn't matter. Just the area of that base times the height. Okay, now when we have a cone, we basically are shaving off a bunch of this material that would have been there. How much do you suppose we're shaving off?
Half?
That's what a normal person would say. In actuality, it's 2/3. Notice that if you only shaved off a half, if I took a meat cleaver and cut this candle right there, I would not end up with a cone. I would end up with an object that had a straight edge at the top.
Okay.
So when you create a pointed edge, you have to get rid of more than half. So you lose 2/3. So the area of a cone is 1/3 pi r squared h.
All right.
Okay. And it's the same for the volume. I meant the volume, not area, excuse me. It's the same for the volume of a square pyramid. Now, first of all, I have to learn how to draw a square pyramid. Let me draw it like this. If you have a square pyramid, the difference between this square pyramid and a rectangular brick, if it was a rectangular brick, it would be the area of the base times the height, right? Well, this goes to a single point. So again, when you go to a single point, you lose 2/3 of the volume. So the area of this brick, excuse me, once again, I don't know why I can't stop thinking area. The volume of this regular prism, no, it's not a prism, what is that? Pyramid. The volume of a pyramid is also 1/3. It's not pi r squared, it's the side squared, this being s, times the height.
All right.
So this same principle holds whenever you're going to a pointed middle. You lose 2/3 of the volume. So the remaining volume is always going to be 1/3 of what it would be if this was a straight object, straight up and down, where everything was the same. So that's one way to memorize it, is that it's always 1/3 when you're dealing with a cone or a pyramid.
All right.
Now with a pyramid, that's correct. That is correct with a pyramid also. Surface area is a little strange on a pyramid, but okay, so the volume of this cone, we've already figured out that it's 1/3 pi r squared times height. So what is that here?
All right. So they want us to use pi. So we go 1 divided by 3 times 3.14 times 11 squared.
Uh-huh.
And the height is 15.
Right. They mean the vertical height there, not this slant height.
Right.
So let's see. Can we approximate this? That's 121 times 15 would be 1210 plus 600. It's going to be about 1800 and change, because that goes to a little bit more than 1. So it's either 1899 or 1911.
It's 1899.
I guess they didn't want us approximating that one because they put two answers pretty close to one another. Okay, what would this one be?
Alright, so you go 1 divided by 3, so 1 over 3. Alright, I am doing the right one. 1 over 3 times 3.14 times, where is that, times 13, is that what that says?
Uh-huh.
13. And
Square. Don't forget to square it.
Right, times 14.
Right.
And that comes to 2,476.
Again, they didn't want us approximating it. Now the volume of the square pyramid, just treat it like it's a cone. So the volume is going to be what? 1/3. The area of the base is sides. 1/3. The area of the base is the side length squared times the height.
Alright, so you go.
And there's no pi involved, notice.
Alright.
The reason is that we don't have a circle. Pi is only going to come into play when we have circles. When we have squares, rectangles, and stuff like that, there's not going to be a pi in there.
Alright. So the side length squared, that'd be 11 squared, right?
Right. What's the height?
The height looks like it's 12. Is that, yeah.
So 121 times 4, 484.
Yep, that's what I got.
Same problem.
Alright, so 1 divided by 3 times, what is that, 18 squared times 19 comes to 2,052.
All right. Hold on. Okay, so this is a shaded area problem. They want the volume of the metal that's left over after a cone-shaped hole is drilled into it. So how are we going to figure out this volume of this other area here?
I don't know, because it doesn't give you any dimensions.
Well, it does. The cube is 4 centimeters.
Okay.
And they're assuming that the diameter of the cone is 4 centimeters also.
Okay.
And the height of the cone would be 4 centimeters. But conceptually, how are we going to do it? Shaded area problems are always what? They're subtraction problems.
Right.
So what are we going to subtract here?
Find the volume of both of them and subtract it?
Correct. What's the volume of the cube?
It'd be 4 times, oh God, cube. I don't remember that. 4, is it pi r squared times the height?
No. We're talking the volume of the cube. There's no circles involved, so it's not going to be pi.
Side length?
What's the volume of a rectangular brick equal to? All 3 dimensions. What are the 3 dimensions? That dimension, and that.
Oh, base times height?
Times width. In other words,
right.
when you're dealing in a 3-dimensional object, there's only 3 dimensions. There's this dimension, there's this dimension, and there's this dimension. In this case, they're all 4. So it's 4 cubed, or 64 cubic centimeters.
All right.
Now we need to figure out the volume of the cone, because we're going to subtract that. To get the volume of the remainder, we're going to subtract the volume of the cone. So the volume of a cone is once again what?
1/3 of the radius squared times pi.
1/3 pi r squared times h.
Times the height.
In other words, here's the area of the base, the cone.
Okay.
The height, just like a uniform object, but only 1/3 because it's going to a point, not solid all the way down.
All right.
So 1/3 pi r squared h. What's r?
The radius, didn't they say it was 4 centimeters?
No, what is the radius?
I don't know, I can't see.
Okay, if the diameter of that circle is 4, what's the radius?
Oh, then it's 2.
And the height?
The height would be 4 as well, right?
Okay, what's that number equal to?
16.74.
So the difference between these two looks like it's 37.26. 47.26.
Yeah.
And they rounded it to the nearest. This is a different test. Usually they only give one answer anywhere near it. But this one is different. So I guess it's 47.3, huh?
I guess.
Well, if we round this up, it becomes 47.3.
Yeah. All right.
It's certainly not 47.4.
Uh-uh.
All right. All right.
And then I was wondering if we could go over surface area one more time. We did on Monday.
Sure. So we want to do 11.1, 11.2.
11.3.
11.3. Okay. Now surface area is actually harder than volume.
Right.
Because you have kind of these special formulas. For a pyramid, the surface area, well, first of all, surface area is always the area of the base plus the lateral area.
Right.
So for this, what's the area of the base?
4.
Now the lateral area is the one that's a little strange. For a rectangular pyramid or a square pyramid, what is it? Do you remember?
No, I don't.
It's 1/2 lambda, which is the lateral or the slope.
Slant height?
Slant height, thank you, times the perimeter.
So the perimeter would
And
be...
notice that the slant height is not the edge of the pyramid height. It's more like the apothem height.
Alright, so it'd be 4, yeah, 4 times 8, and that's
Or
32.
Plus, okay, so 4 plus 1/2, the slant height is 8. Perimeter is 8 also.
That 4 wouldn't go in there then.
Well, so all I did was I plugged in everything. We got the area of the base, 2 times 2.
Oh, okay.
We got 1/2 the slant height, which is 8, times the perimeter, which is 2 plus 2 plus 2 plus 2.
Right, which is 4.
Right, so this becomes 32 plus 4, 36.
Yeah. I didn't add in the area. That was my problem.
Okay, surface area of a cone. Slightly different formula. Surface area of a cone is the area of the base plus 1/2 pi RL, if I remember correctly.
Alright, so you get...
It's the area of the base.
So you got 3.14.
No, they want the answer in terms of pi, so we're not going to convert it to 3.14 this time.
Alright, so 3 squared is 9 pi plus half of pi r, so half of 3. No, it would be half of 9, wouldn't it? No, okay.
No, the radius is 3.
Right.
What's the slant height?
You'd have to do it in terms of Pythagorean theorem, wouldn't you?
Yes, unless you recognize that that's a special triangle. What kind of triangle is that?
3, 4, 5 triangle.
So the slant height is?
5.
So we have 9 pi plus 7.5 pi. So we have 16.5 pi.
All right.
Find the lateral area and the surface area. So let's do lateral area first. What's the formula for lateral area of a cone?
Pi RL plus pi r squared.
No, not the lateral area. The lateral area is just that. Is it pi RL or is it 1/2 pi RL?
It would be 1/2.
I don't know. I'm going to have to look it up. One thing I don't remember is my surface area formula. Because I might have done the last one wrong. 735. Seems like I did 1/2 last time, didn't I? For a pyramid, it's 1/2 pi, or 1/2 perimeter times the lateral area. For a cone, it's pi RL. There's no 1/2. It's just pi RL.
Okay. All right. So does that say leave your answer in terms of pi? Can't
Yes.
see it.
Well, actually, no. I don't see any pi's in answers. So we'll have to use 3.14.
All right. So
Radius?
the radius is 5, so 25 times 16.
Where'd you get 25?
You square the 5. Oh, no, you don't.
No, you
Sorry.
don't. It's just pi RL
Okay.
for the surface area. Or the lateral area, it's just pi RL.
All right. 3.14 times 5 times 16. And that gives you 251.2.
Okay, now we immediately know that the answer is none of these because that's not on there. But let's go ahead and figure out the surface area anyway. What would the surface area be?
The surface area is half of the pi times the...
Actually not. The surface area is the area of the base plus the lateral area. So what's the area of the base?
25 pi.
Correct. So plus 251.2. The answer is not on there. There was no answer of 251.2 for lateral area.
Alrighty.
Okay. Notice this couldn't possibly be right because this has a surface area less than the lateral area.
Yeah.
Surface area has to be more than the lateral area. So.
Alright.
Okay. Surface area of this.
So this one is half times...
Well, let's do this in 2 parts also. Even though they didn't ask for it, let's do the lateral area. What's the lateral area equal to?
Pi r times the...
No, there's no circles. Remember, pi is not a factor if there's no circles.
Right.
Pi only comes in when you have a cone or something like that. So
times height times width?
no, just the lateral area here. Let's not count the base. The lateral area is 1/2 the perimeter times lambda.
Alright, so the perimeter is 28, so that'd be 14, and then the lateral length is 7 times 14.
So the lateral area is 98. What's the area of the base?
The area of the base is 28.
What's the area of that square?
Oh, the area, I'm sorry, 49.
Okay. So the total surface area, being the lateral or the base plus the lateral, is equal to what?
Base plus the lateral, so 49 plus 98.
Which would be 147. But in this problem, they did ask for just the total surface area, so we want the 147 answer.
All right.
And another cone.
Okay, so this one for surface area is half pi RL.
No.
Is that for lateral area then? Because I'm confused on what that one
Yeah,
is.
so let's go through the 2 lateral areas. We have the lateral area of a cone, which is pi RL. We know we're going to have a pi because it's circular in nature. And then we have the lateral area of a pyramid, which is not circular in nature. And the pyramid is the 1/2 perimeter times L. So here's the distinction between a cone and a pyramid. This figure in question 4, that's a pyramid. In question 5, that's a cone. So the only thing we have to do to get the surface area is to add the area of the base in both of them. So the surface area of a cone is going to be what?
Surface area of a cone is the area of the base times...
Which is what? Pi r squared.
So 100 pi.
Plus pi r L. This is what I want you to remember.
All right.
Okay, we can always fill in the numbers, but what you're having a little difficulty with is remembering the formula. So the surface area of a pyramid would be what? Number 4.
Pi.
No.
Oh no, it wouldn't be pi. It'd be the radius.
There's no radius, but there's a side length.
So
it's the area of the base. That's this.
Area times the side length?
No, just the area of the base plus the lateral area. So there's your two formulas for surface area of a cone and a pyramid. Notice how they differ. The lateral area of the cone is pi RL. The lateral area of the pyramid is 1/2 the perimeter times L. No pi. There's no pi in the surface area of a perimeter at all.
All right.
In the cone, there's a pi in the area of the base, and there's a pi in the lateral area also.
Okay.
So just remember that the half comes in only on this lateral area of the pyramid.
All right.
So this page right here is what you want to memorize, because some of these questions ask you about lateral area and some ask you about surface area. The only difference is the surface area is the area of the base plus the lateral area.
All right.
Okay. So the total surface area number 5 then is going to be what?
All right. Surface area of a cone. So 100 pi of a cone plus pi r. So you do Pythagorean theorem here to get the lateral length, right?
Right.
All right. So you got 10 squared minus 24 squared.
No, the hypotenuse is always the sum of the other two.
Right.
So it's the square root of 24 squared plus 10 squared.
Plus 4 squared. Alright, I guess. Okay. Nope, my calculator is having difficulties. 10 squared plus 24 squared equals... Okay, so the hypotenuse is 26.
Okay, so it's times 26. So we have 100 pi plus 260 pi. Something's wrong.
Whoops. Wrong, because the answer's on there.
Where is it? I get 360 pi. I guess none of these. In other words, I have 100 pi for the area of the base.
Right.
Plus I have pi times 10 times 26, so that's 260 pi. So I have 100 pi plus 260 pi. That answer is not on there. right, what do we do here? And the surface area in terms of pi. So let's figure out this one again. What's the area of the base?
The area of the base is 9 pi.
What's the lateral area? Pi r L, and L is 5. Ah, I know what we did. We took half of that. That's where I made the mistake. I applied the wrong formula. I was thinking it was 1/2 pi r L, and it's just pi r L. So 24 pi is our answer.
Okay.
Yeah. That was my fault. Apologize. So the most important thing to remember for you are these 4 formulas right here.
Right. I wrote them all down. I'll work on studying them tonight.
Okay. Because they're a little different from one another, depending on whether you're talking pyramid or cone, particularly this 1/2. But the other important thing is to remember that with pyramids, you don't have a pi involved, and with cones, you do. You have a pi for the area, and pi is also involved in the lateral surface area.
Right.
Okay.
Right. Well, that's all I got for today.
Okay. That sounds good. I've got
And then I canceled over next week and then 2 Mondays from now.
Right. I got you down as the next appointment for you is Wednesday the 3rd
All right. Sounds
of
great.
April. No, hold it. Yeah. This is the 20th. Okay. Sounds good. Well, have a good spring break, Ryan.
You too.
Okay. Bye-bye.